All right, let's jump right in. Today we're going to talk about a practical framework for tackling one of the biggest challenges in medicine today. How do we get the data we so desperately need for research in AI without risking the privacy we owe our patients? This is a guide for the real world, for all you clinicians and researchers out there. So let's get into it. You know, if you're in healthcare, you live this tension every single day. On one hand, there's this urgent, almost desperate need for more data. We need it to train our AI models to run faster clinical trials. But on the other hand, we have this absolute non-negotiable duty to protect our patients. So how do you even begin to solve that puzzle?
And this slide just lays it out perfectly, right? Over here, you've got the engine of progress, AI, research, you name it. And over here, you've got the absolute bedrock of our profession, patient trust, confidentiality, and our ethical duties. For the longest time, it really felt like a zero-sum game. It felt like you couldn't push one forward without sacrificing the other.
But what if it's not an either-or? What if there was a way to fuel all that innovation while actually strengthening privacy? Well, that's exactly what we're diving into next, a breakthrough that really offers a path right through this dilemma.
Okay, so the answer, it's called synthetic data. Now, this isn't just anonymized data where you've, scrubbed out some names and addresses. No. This is entirely new, artificially created data that mathematically mirrors the original patient group. It captures all the same patterns and relationships, but without being tied to a single real person.
And this is the part you really got to wrap your head around because it's a huge deal. The key word here is creation, not redaction. So instead of taking a real patient's file and just blacking out their name, you're literally creating a brand new, totally artificial patient profile. It's like a digital twin that's statistically identical to a real person, but with absolutely zero link to an actual individual.
Okay, so this sounds amazing in theory, but for anyone actually working in a hospital or a lab, you're probably thinking, great, but how do I actually do this? Well, let's get into a practical blueprint that was designed specifically for clinicians and healthcare organizations.
So this framework, it breaks what seems like a really complex process into 3 super logical stages. It's a clear path. First, you plan what you need and you create the data. Then you test it to make sure it's high quality and you secure it. And finally, you implement it with strong ethical governance. So in that first stage, it is all about defining your mission. What's the clinical problem you're trying to solve? Are you designing a clinical trial and you need a synthetic control arm to speed things up? Are you trying to train a diagnostic AI, but you just can't use real patient images? Or maybe you're researching a rare disease, and there just isn't enough data to go around. It all starts here.
And what this chart makes really clear is that there's no single magic button here. One size does not fit all. Different types of data need different tools. For simple spreadsheet data, something called a copula might be perfect. But for that complex, messy data from an electronic health record, you might need a more powerful model like a CTGAN. It's all about picking the right tool for the job.
Okay, you've made the data. Now for the million-dollar question. Does it actually work? This is that crucial second stage. And the gold standard for testing it is pretty straightforward. You train one AI model on your new synthetic data and another on the original real data. Then you test both of them on a completely separate set of real patient data. If the model trained on synthetic data performs just as well, you know you've got a winner.
And look, the final stage, implement and govern, this is where the rubber meets the road, ethically. The tech is only one piece of the puzzle. It really comes down to this quote here. Success hinges on our commitment to ethics, to patient well-being, and to building trust. This is where we as clinicians have to partner up with our ethics committees to make sure we're using this incredible tool responsibly.
All right, so that's the theory. That's the blueprint. But what does it look like in the wild? Let's check out some real-world results, because this is where it gets really exciting.
Check this out. Sanofi, by using these synthetic digital twins for a control arm, was able to cut a full 6 months off an asthma clinical trial. 6 months! I mean, in the world of drug development, that is an eternity. Think about the resources saved and how much faster they can get answers to patients. And we're not just talking about high-level research either. This is about making hospitals actually run better. Duke Health used an AI model that was trained on synthetic data to optimize their logistics, and they saw a 66% drop in the time it takes to assign a patient a bed. I mean, that is a huge win for hospital efficiency and for the patient experience.
Okay, this is a total game changer, especially for anyone working with AI.
By taking just a small 10% sample of real data and boosting it with high-quality synthetic data, researchers saw a model's accuracy leap from around 71% to over 82%. That's massive. It means we can build powerful, accurate models even when we have very little real-world data to start with.
Okay, let's be real. This isn't a silver bullet, right? It's not a magic wand. Like any powerful new technology, there are some pretty big challenges and limitations that we need to be clear-eyed about as we move forward.
And these are the hurdles we absolutely have to clear. If your original data has biases baked into it, guess what? The synthetic data will too. And it could even make them worse. And we have to answer these tough questions, like who's liable if something goes wrong? Who actually owns this new data? These are critical conversations we all need to be having right now.
And all of this really leaves you with this one big, kind of provocative question. It makes you wonder, what if our biggest roadblock isn't a lack of scientific ideas, but a lack of the right kind of data to test them? Synthetic data isn't just about creating artificial information. It's about unlocking real human potential.
So this entire practical framework we just walked through, this is the work of Dr. El Mostafa Bouate. For any clinicians or researchers watching who want to go deeper on this, and maybe even explore implementing it in your own work, I really recommend you connect with him on LinkedIn. Thanks so much for joining us.